In this part of the video, we are going to look into C++ template class and template functions. So let's first look at this template class. So we have a class and we name it list, and the syntax looks like this. If you say template class E, here the class doesn't mean this class. It's just a keyword, and it could also be called type name, something like that. And but here we just use this keyword, but it has nothing to do with this class. So we say template class E. That makes this whole class a template class. And what that E means, you can view it as a type holder. So for example, you see I'm trying to model a list of something. So by convention we use some uppercase single letter to as a place as a type holder here. So this E could be replaced by int, some built-in data type, float, char, or some user-created data type like our student data type. So it's just a type holder here. And we are trying to model a list of something. So essentially we are trying to model a very simple vector here. So a list of something by using dynamic array. You see we have a logic size, we have the capacity, and we have the growth factor just in case we need to grow our list here. So and here we have the constructor, the destructor, we make it virtual just in case somebody want to extend us, want to be subclass of us, and we provide a copy constructor because we have dynamic memory there. And we overload the assignment operator, the get size, and we overload the plus operator. That means you can add individual element to a list object, and we overload the bracket operator to provide easy access to individual element based on the index. Alright, you see when you have a template class, that makes this member function template, but you don't have to say template class E here. Again, you can only say it here. But take a look at the difference here. For this one, for operator insertion, for this function, because it's a non-member function, and we make it a template function because it acts on this E, it needs to use this E as well. So we have to declare it as a template function because it's a non-member. And this one is a template function as well, but we don't have to declare it. We already declared it here before the class declaration, so we don't have to declare it here because this one isn't a member function. We have to explicitly declare it's a template function. Alright, and same here. For this operator equality, we have to declare it as a template function. But you know those ones are all template function because we declared here, so we don't have to declare individually for each function. So now let's take a look at the implementation of list.cpp here. For list.cpp, the implementation, one thing you need to the logic, you're already familiar with how to use a dynamic array to implement a list. So that part is trivial. We already know that. But some syntax wise, I want to point it out. Like for every function implementation, because the template function, you have to declare it everywhere. Like for every function, before you do it, you have to declare. That's something you need to pay attention to. Other than that, the logic isn't any different. So I'm only focusing on the difference, the differences introduced by using templates here. So you see for every function, you have to do that. Template, template, template. So that's the implementation part. And the other thing that's kind of trivial, but you have to understand is the header file and the specification of the template and the implementation of the template should stay together for the compiling purpose. Because the object code cannot be generated until you invoke it. Like for example, here when we have a list of integers, then the code can be generated. When we have a list of student, then the code can be generated. So in order to keep the header file and the implementation file together for the compiling purpose, sometimes people take one of two approaches. One of them is you put the implementation right here, like here. You put the implementation right here for every function. That's one approach. But for that approach, it kind of violates our purpose of separating the implementation from the specification. But for this purpose, it's alright if you want to implement it right here. So you don't have to have a .cpp file to hold the to contain the implementation. You can implement it right here in the header file. That's one approach. And the approach we're taking is we still separate them. We have a header file and we have a cpp file. But you see something weird here. At the end of the header file, we include the list of cpp here. So remember, the include directive simply copy paste the list of cpp right here in the same file. And so essentially they're still together in one file. That's why we do it. This might be the only place you ever include a cpp file. We never include cpp file before templates is introduced. So we include list.cpp. Essentially we copy paste them in the same file. And another thing I want to point out is, you see this one, the list.cpp. If I write, you see that little minus sign? If I right click on the property, so by default this one is no. I have to set it to yes, excluded from build, because if I don't do this, it's get included twice in the code, get built twice, so that will introduce lots of trouble. So I have to say exclude from build because it's already included in the header file. So that's what you need to pay attention to. So that's about using templates and the syntax that's involved with using templates. So let's take a look at the client code about using the templates we just defined. Okay, test list templates. So when we use list templates, we have to provide type information here. So to replace that E, that uppercase E here, so we create an int list copy, and we use overloaded addition operator, and we use that insertion operator as well. We overloaded, and here we are using that's for integer. Here we have the student list, and we use the addition operator, the insertion operator, to do the testing here. So you see, when we create this list template, we can give it a list of integer, we can give it a list of students, so it should all work. But one thing I want to point out is, for your list implementation, like for example, when you do the addition operator, you're assigning this item to you're appending this item to the end of the array. So it's assuming you overload this assignment operator appropriately, including the deep copy, etc. So you should, so it's assuming the individual elements, the E, the type E, already take care of this. And another example, like for example here, go ahead and insert this element to the output stream. Again, it's assuming the insertion operator is overloaded for the individual element. So for example, when we use it as a list of student, it's assuming student class already overload. You already overloaded the insertion operator for student class. So that's some assumption here. And again, it's assuming the equality operator is overloaded for individual element of the list. Thank you.